Now my dear, you are well aware of the concepts of planes and lines by this time. We have seen the same thing in Cartesian lecture, cylindrical lecture. The same concepts are applicable over here also. If out of 3 coordinates, if one is given constant, rest 2 are variables within their full limits, then it represents a plane or surface. If out of 2 were constants, only one is variable, then it represents a line. Am I right? So same concepts are over here also. So let us consider r equal to constant. Let us find out the locus for r equal to constant, phi and theta. Let us assume they are variables within their full range. For simplicity, assume r equal to 2. So as we already know, one coordinate is constant, that means it is going to represent a surface. So r equal to 2 will also be a surface as it is. It is a spherical surface having radius equal to 2. You know my dear, each and every point present on this surface will have r coordinate equal to 2. Because all the points on this surface are present on the same sphere of same radius. Am I right? If r equal to 5, let us say the locus for r equal to 5. So again it will be a spherical surface like this. Again it will be a sphere of radius 5. If r equal to 10, phi and theta, let us say they are variables, then again it will be a sphere but with radius equal to 10. So you know my dear, r equal to constant is going to represent a surface, a spherical surface having radius equal to that r. Now phi equal to constant, we have already seen that phi equal to constant represents a vertical half plane attached to the z-axis. Am I right? We have seen that in the cylindrical coordinate system lecture. The phi coordinate is exactly the same in cylindrical and spherical. So the same concept is applicable over here also. Phi equal to constant will be a vertical half plane attached to the z-axis. Last one, theta equal to constant. R and phi, let us assume they are variables within their full range. Again for simplicity, consider theta equal to constant at theta equal to 30 degree. So we want to check out what is theta equal to 30 degree surface, or we want to find out the locus of all the points having theta equal to 30 degree. So theta equal to 30 degree surface is like this. This is the inverted conical curve surface having apex at origin. All the points that are present on this surface, all the points have theta equal to 30 degree. Check out P, its theta is 30. Check out Q, its theta is also 30. Because you know, we have drawn this conical surface such that its apex it as origin and its slant side is making an angle 30 degree with the positive z-axis. So if you take any point on this surface, its r is going to make 30 degree with the positive z-axis. So my dear, all the points on this surface are making 30 degree or having theta equal to 30 degree. So this is our theta equal to 30 degree surface. If theta equal to 60 degree, the surface will be like this. So my dear, you can remember like this. Theta equal to constant, r and phi, they are variables, represents a conical curved surface, inverted conical surface having apex at origin and its slant side making an angle theta with the positive z-axis. Now in this case of theta equal to constant, there are few interesting points that you must know. We have just seen how theta equal to 30 degree and theta equal to 60 degree surfaces look like. These are like this, the inverted cones formed above the xy plane. Am I right? My dear, both the angles that we have considered were less than 90 degree, less than pi by 2. Now let us assume theta equal to 120 degree surface. That means angle greater than pi by 2. So theta equal to 120 degree surface will be like this. It will also be a conical surface having apex at origin, but it will be formed below the xy. So my dear, you should remember like this. Theta equal to constant represents a conical surface whose apex is at origin. But if theta is less than pi by 2, then that conical surface is formed above the xy plane. And if the theta is greater than pi by 2 to pi, then that cone will be forming below the xy. And now my dear, what if theta equal to pi by 2? If theta equal to pi by 2, that theta equal to pi by 2 surface will be like this. It will be exactly same as the xy plane. So r equal to constant, phi and theta variables, it represents a spherical surface, a sphere having radius equal to that r. Phi equal to constant, it is exactly the same as in cylindrical coordinate system. It is a vertical half plane attached to the z-axis, making angle phi with the positive x-axis. And theta equal to constant, rest two are variables. As we have just seen, it is a conical surface having apex at the origin and whose slant side is making an angle theta with the positive z-axis.